Hey class, today we are still talking about quadratic formula, but this one is found in section 4-7, part 2 of your book. We're going to determine the number of solutions by using the discriminant. All right, so the discriminant is the part of the quadratic equation that's found under the radical symbol. So in other words, it's the radicand of the quadratic formula. So based on the solution, based on the value of your discriminant, it'll tell you how many solutions you are supposed to have. So for example, if the radicand is positive, you're going to have 2 solutions. If the radicand is equal to 0, then there's 1 solution. And if the radicand is a negative, then you're not going to have any intercepts or any x-intercepts. So let's try this. All right, in example 3, we're using the discriminant to figure out the number of real number solutions found in this equation. So, to figure out what the discriminant is, remember that's the radicand of the quadratic equation, so that is b squared minus 4ac. Okay, so our a is -2, our b is -3. Our c is 5. So all we're going to do is substitute. So b squared would be -3 squared minus 4 times a, which is -2, times c, which is 5. -3 squared is 9. -4 times -2 is +8, and +8 times 5 is 40. We know that's going to be positive. So remember, if it's positive, that means that there are 2 real number solutions. And we're done. Okay, so let's try this again. Remember, it has to be in standard form. So the first one is in standard form. So a is 2, b is -3, c is 7. Okay, so that's b squared minus 4ac would give us -3 squared minus 4 times 2 times 7. That's 9. That's -8, and then -8 times 7 would be -56. That's going to give us a negative. We don't even really need to know what the number is. It is a negative. And since it's a negative, we know that there are no solutions. No solutions there. All right, and then the last one. So I mentioned it has to be in standard form, and this one is not. So if I subtract 6x and subtract 5 over, that'd be x squared minus 6x minus 5 equal to 0. So if I substitute into the formula, that would be -6 squared minus 4 times 1 times -5. That would give me 36, and that would give me +20. That one is going to be positive. And so, once again, that is 2 solutions. All right, in example 4, now we're using the discriminant to figure out will something reach a particular height. So let's just go through the word problem. It says you hit a golf ball into the air from a height of 1 inch above the ground with an initial velocity of 85 feet per second. The function below models the height in feet of the ball at time t in seconds. Will the ball reach a height of 115 feet? Check using a graphing calculator. All right, so here's the deal. The only piece of information that is important from the word problem is the 115 feet. So the 115 feet represents height. Okay, so our height would be 115, so I need to substitute that in. So 115 equals -16t squared plus 85t plus 1/12. Well, even to deal with a discriminant or anything dealing with quadratics for the most part, we need to be sure this is in standard form. So to get that in standard form, that would be 0 equal to, because we subtract 115, so it's 0 equal to -16t squared plus 85t minus 114 and 11/12. And I got that because I subtracted 115 on both sides. Now from here, remember, we're going to do the discriminant. So it's b squared minus 4ac. So that's b, which is 85. So 85 squared minus 4 times a, which is -16, times c, which is negative 114 and 11/12. Okay, let's figure out what that is. So in my calculator, let's see. 85 squared is 7,225. And then let's see. Negative 4 times negative 16 gives me 64. Then I multiply that times negative 114, 11/12. So that's going to give us negative 7,354, and basically that's 2/3. And then if I continue past that, 7,225 minus 7,354 and 2/3 will give us negative 129 and 2/3. And really I didn't even need to solve that, because I would have clearly have been able to see from the last step that our answer was going to be negative. Oh, so since it is negative, we're not going to have any solutions. So if we're not going to have any solutions, that means that the ball will not reach a height of 115. So no. And we can check that in our calculator. And the way we can check that in our calculator is by typing this part here into the y equals section, and also typing in y equal to 115 feet. If you get your window correct, what you'll notice is that the vertex, so if this is 115, your graph will not reach that line, okay? So no, the ball won't reach a height of 115 feet. So now, if we go back and ask, will the ball reach a height of 110 feet? Okay, so we use the same formula that we just dealt with. So I'm just going to go to the part where we were left with it already being in standard form. So that was 0 equals negative, well, actually, I guess I can't because I have to do something else, so never mind. 110 equals negative 16t squared plus 85t plus 1/12. And what I'm going to do, because I'm not going to keep dealing with fractions, I'm going to go ahead and change that to a decimal. So 1/12 is about 0.0833. So anyways, that would give me negative 16t squared plus 85t. And then this will give me minus 109 point, and I'm just going to round it, 0.92. All right, so from here, we would then do the discriminants of b squared minus 4ac. B squared is 85 squared minus 4 times negative 16 times negative 109.92. 85 squared is going to give us 7,225 again. Negative 4 times negative 16 is about 64, and then if I multiply that times negative 109.92, that's going to give us negative 7,034.88. So again, even without solving, I know that this answer Actually, yeah, without solving, I know that this answer is going to be positive because 7,225 minus 7,034.88 is going to give us 190.12. So yes, it is going to reach a height of 110 feet because it would have two real solutions. And that is it. So guys, if you have any questions, be sure to come in for tutoring.